Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy. I will be your moderator. We are recording this podcast from the floor of the SmallSat conference here in lovely downtown Logan, Utah. Metropolis of the world, much bigger than London, much bigger than Tokyo. Our guest today is Dan Hegel. He is the Director of Advanced Development at Blue Canyon Technologies. He is going to talk about the business of small satellite companies and the military and commercial space companies' interest in small satellite development, making it the most hotly competitive part of aerospace. And in spite of it being this hotly competitive, his company is really killing it. In fact, Blue Canyon has been doubling the size of their company every year. The growth is explosive. Your company has been very successful. Dan, do you think this kind of growth will continue for small satellite companies in general?
Well, I don't know about all areas of the space market, but I think with small spacecraft, yes. There are a lot of peripheral companies, generate products, propulsion, payloads, data analytics, various component manufacturers, etc., which keep popping up daily, seems like. I mean, you walk around the field house, it's just amazing how many companies. But, they tend to water down the market. So, yes, there is, the demand is growing rapidly, explosive, but so do the number of companies, as they're filling that demand. So as that demand increases, so do the number of companies and kind of waters down the growth potential for a given company. But I think BCT, Blue Canyon, is unique in that there really aren't that many players producing the high-end small satellites in our price class. So for us, we see, the continued explosive growth.
And it really is. I mean, even last year the parking was easier than this year. Next year we have to park, way far from here. It's like so many people here. Early in the morning here, all kinds of people running around at the SmallSat show. What I also see is that, we see a lot of successful companies out there, and I see small satellite manufacturers are being acquired or maybe forming partnerships with big primes. Do you think that trend will continue? And do you think we'll go full circle and back where we started? Yeah,
that's a good question. Very hard to predict. It really depends on the culture and vision of each company, what their goals are going in. A lot of people spawn these small companies because they don't want anything to do with the big guys and just not in their DNA and no goals to do that. Each company is very different. I can't speak for Blue Canyon as to where we'll be 1, 5, or 10 years from now. That's above my pay grade. But speaking more broadly to include other spacecraft products, as talked about earlier, payloads and propulsion and radios, I don't see any shrinkage in the number of companies. I mean, we're talking about the size here. For example, this conference, just a few years ago, everything was housed, all the booths in this one building, Taggart Student Center, and now it's overflowed into the field house, where it seems like there are probably twice as many booths over there. It's jam-packed. If anything, it's going the other way. I don't see consolidation. I just see a proliferation of new ideas, new innovation. What is their long-term vision? I'm sure that there are many who would love to get swallowed up by a big prime. That's their goal. They go in, let's make a flash, get noticed, get bought up. Others want nothing to do with it.
Yeah, some people just want to live in Colorado, do exciting things, and ski on the weekends, and have fun, and be innovative and creative. And if you look around here, I think that's the key. I've done, dozens of interviews here on Constellations, and there's so many people, so many good ideas. And I think, the small companies give that flexibility to try things. Against this ability to fail a whole lot. Let's try this. Oh, Dan's going to get mad. No, try this, try that. And so the flexibility and looseness allows for that creative process to take place, where the larger companies may not have that wiggle room.
Right. Yeah, there were. I remember, for example, one of our younger engineers hired. He was probably less than a year out of college, and we had this little interface device to talk to our hardware, and then do some protocol conversion, a little thing that was, half the size of a deck of cards. And we wanted to put on an air bearing, but we need a wireless, because on an air bearing you can't have wires and stuff, it'll get in the way. And he said, how about I just put some Bluetooth on this and just set up to be wireless. It's like, well, you can do that? Well, he's like, and just over the weekend he did it on his own, just took his time. No real approval process. In a big company that would have required, IRAD funds, and months of approval process, and it was done over a weekend, worked exquisitely, and
that guy could have quit in frustration.
Yes,
that's
exactly,
the thing. Yeah.
Exactly.
So I think small satellite companies bring innovation to the table. But if you're a large prime or an organization looking to put something in space, why would they choose a small satellite company over a big proven prime? Why would they choose you guys?
Well,
and they are, by the way, aren't they?
Yes, absolutely. A lot of it is that the flexibility, less process. You go to a big prime, they've got their standard way of doing things that's been done for decades, and that's all that their employees know. And so you try and get something done fast, it's just not in their DNA. Just paperwork, just a contract's nightmare. And also just the cost. So because of the way they've done it for decades, they've got their parts, their way of doing it, level 2 parts, rad hard, S-class, whatever. So right away, you're talking bigger form factor, more expensive parts, longer lead times to get those parts. So they just really don't know. Their engineers haven't been trained how to use those cheaper parts, where to go, what is usable, what's not. And innovation, a lot of them are kind of doing the same old thing and not looking out to see what's being done differently. Whereas the small companies are just naturally looking for the newest, latest technology. And also you get a lot of this, it's just the way we do it at company XYZ. So don't look to be innovative. This is just the way we do it. It's a tried and true process. It works. Don't rock the boat. Don't take risks. But also another thing that you have at the primes, very specialized, very deep, which is great. I mean, the primes will come up with some amazing missions, some amazing mission analysis, phenomenology. They'll have a staff of hundreds of PhDs who have knowledge of their little sliver of the electromagnetic spectrum so they can figure out exactly how to do something. But to get something done then, because everyone's so specialized, it requires many more people to cover all the bases to get something done. And that adds a lot of cost and time with all the interfaces and communication. Whereas with a smaller company, you're forced to be more interdisciplinary. You take on many roles. Yeah, you don't have a choice. I mean, for example, so I was chief architect of our attitude control system as a GNC lead in the early days of the company. And we would do power analysis. I would work with the systems engineers. And they say, well, if we fly this direction, what will the solar arrays see? How much power will they get? And then they would feed it into an Excel spreadsheet to do power calculations. And I got tired of doing all that, so I put together a simulation that models the power system and the attitude control to do this unified analysis. And I knew nothing about power, so I just became a junior power engineer, interviewing, talking to our power guys. So how does the battery charge? What do the equations look like? And just learned enough where I could program all that. And we now have this really slick tool that within a matter of hours, you've completely analyzed the spacecraft.
Great.
But out of necessity, because we just didn't have the people.
Let's jump around and talk about NASA here. Now, recently, your company, BCT, was selected by NASA to collaborate with 2 universities to provide multiple spacecraft for NASA's LaserCom infrared crosslink, called CLIC, small sat flight demonstration. Similar to what you just did. So tell us about CLIC, if you can.
Yeah, sure. Well, I'll just repeat a lot of what was in a wonderful paper yesterday during one of the talks by one of the MIT students. We're building 3 spacecraft, 3 of our 3U CubeSats. CLIC has like 2 phases. There's CLIC A, which is to demonstrate LaserCom to the ground, and then there's CLIC B and C. They'll launch sometime later, and those are for intersatellite communications and time transfer. So they'll be able to communicate with each other, but also equally importantly, be able to transfer time and their position and velocity, which is important when you want to try to do synchronized measurement collection. Innovations
in satellite communications have been standard for years and years. Something new's coming in and improving it with speed, reliability. It's just crazy, isn't it?
Yeah, we're working with Stanford also on, MIT, on the Tropics program as well, some other programs. So we have a really good relationship with MIT. And looking forward to this program.
Speaking of programs, there are many programs that need precision pointing capability. and they've been driven to acquire rides on large spacecraft or purchase large spacecraft bus. The engineers at your company at Blue Canyon found a way to fit that capability into a miniaturized package. Can you talk about how this might be an example of small satellites becoming mission-ready for government and commercial applications?
So our company, the flagship product, is our Exact product, XACT. And that was started by an SBIR with the Air Force. And at the time, they wanted, it was to provide precision attitude control for CubeSats. And at the time, they were just tumbling around, or maybe they get 10-degree pointing. And they thought precision would be 0.2 of a degree. At the time, people thought, well, that's going to be really hard. Well, we beat that by almost 2 orders of magnitude. So we're down around 0.002 degrees. But we designed it for overkill because we had kind of a, if you build it, they will come mentality from the start. Knowing that if you can really do something exquisite, that it's going to enable the market, grow the industry, and which it has. So we're supporting a number of different government programs that people only dreamed about years ago. They just never thought possible. And then there's some NASA programs that we've supported. For example, Marco, that was talked about yesterday as well, that was with JPL, 2 interplanetary CubeSats. They flew from Earth to Mars, 300 million mile journey, and they rode along in formation with the InSight lander and were used as data relays to convey all the entry, descent, and landing information back to Earth during that process. So 7 million people around the world were listening in on YouTube and various podcasts, tracking what was going on, listening to the results, and that was all carried by 2 CubeSats, partly enabled by our attitude control and other small sat technology.
It sounds more clever than anything else. It's, well, who thought of doing that? But you kind of 2 and 3 together and you do something very original.
And there's another mission we did with JPL as well called Asteria. It's a mini Kepler mission where it's looking for planet crossings in front of stars. And they measured our line of sight stability at 1.6 arc seconds RMS, which is equivalent to something like the width of the Empire State Building as viewed from Los Angeles. I mean, it's
incredible.
Yeah, the system points better than 98 to 99% of any spacecraft that has ever flown. So
Wow.
It's really enabling a lot of technology now, a lot of missions.
You know, Dan, thousands of people from all over the world are listening to this podcast. If you are listening and like to get email alerts when new episodes are available, go to Google, type in Constellations Podcast, click on Kratos, give us your email, and we'll keep you update with all these exciting developments, especially from the folks out at Blue Canyon here. Wow. Let me go back to our friends at MIT. A professor from MIT said that Blue Canyon's CubeSat platform will enable new capabilities for coordinated and distributed sensing missions. So we just mentioned these capabilities. So who will benefit from some of these capabilities?
Well, everybody in the world, actually. I mean, it sounds grandiose, sounds kind of presumptuous, but it really is true. One of the areas will be in the way of weather. We're working with multiple companies, programs for weather monitoring. One of them is the MIT mission called Tropics. Series of microwave scanners. We're building 7 CubeSats that will fly distributed around the Earth to provide higher revisit times. And we're also working with Colorado State University and Tempest D. That one's already flying. It's a millimeter wave detector that's able to peer through the clouds and look at moisture content of hurricanes and storms. And the plan there is to have a string of pearls where, like, every 5 minutes a satellite goes over to see how the storm has progressed in 3 dimensions. So you'll be able to do much better job of predicting where storms are going, where hurricanes are going, weather forecasting. So the price of one exquisite weather satellite that may have a revisit time of 3 days over your neck of the woods, you could potentially have a satellite that comes by every 15 minutes. So that will dramatically improve weather forecasting.
This is almost like a recruiting podcast for MIT and Colorado. I mean, this is going to get kids excited and want to go there and study and contribute and really, and this is really what you want to get. You want to get the bright young minds to look at new concepts like this. I mean, who ever thought of doing some of those things, you know?
Right. And even just saving costs, I had heard that, just having 1 or 2 days better forecasting for weather help shipping industries. They go through so much gas, well, and just saves costs, because if they don't know exactly where a storm's going to be, they have to go out of their way and expend extra fuel to make sure they go around the storm because the uncertainty. If they know better where it is, they can take a more direct path and save hundreds of millions of dollars per year on fuel costs.
Well, you pick up your phone, you go to Google News, see what's going on, and you folks, your company, Blue Canyon's been all over the news because DARPA awarded you a contract to define bus and payload requirements for a program. A DARPA representative, and this is from the article, said that the future will be about expendable assets networked together in real time. This exquisite to expendable transition is changing how technology is built, how it's bought, even how decisions are made. I mean, this is like discovering America or something. This is a big, big shift. I mean, from the it's like, oh yeah, it's expendable, but it still works.
Yeah, it's very exciting to be on that cutting edge. So yes, Blue Canyon was one of 3 bus developers. So we just had our PDR last week. It's for the Blackjack program, where DARPA wants to demonstrate up to 20 satellites interacting, formation flying, inter-satellite links and such, to do just a whole new realm of mission capability. And we're very excited. We're developing we think it's an exquisite system. I talked about how good the pointing capability is. It's not a huge platform, but in terms of, again, the pointing, what you can do in a small platform, it is exquisite. And but yet, because of low cost, people will consider it expendable. They're willing to take chances. If they want to deorbit after 3 years and put something up with better capability, fine. As opposed to having some billion-dollar asset that took 15 years to build and say, well, there's no way we're going to take that down.
You know, a few minutes back I talked about picking up my phone and reading Google News, and you can argue that we're all living in the world that DARPA created. You know, I'm getting the news over an internet connection. I got desktop computers and everything else, notebook computers. So what's next? I mean, what direction is DARPA heading? And there must be some initiatives. They're working with companies like yours and MIT and Stanford on different emerging technologies. So what are 2 or 3 of them that might be exciting for the next few years?
Oh, let's see. Mesh networks, I think in space, they're utilizing the up-and-coming mega constellations to route data around to warfighters in the field and other people doing analytics, getting more rapid data to players that need it in a hurry. But laser crosslinks, a variety of different small payloads. So just as they are funding small buses development for Blackjack, they're funding many payloads that can be co-manifested together in ways that couldn't be done before. Low cost, the autonomy, one of the really interesting aspects, I would say the DARPA hard aspect of Blackjack, in addition to the cost, is the autonomy through the pit boss, where it'll be sharing information between these, through the cross links from one satellite to the next, tipping and queuing, say, hey, I saw this phenomenology, queue another satellite, what do you see from yours with your different detector, different wavelength, or and then be able to share information and process that real time, and then send the results to user in the field saying something was detected of interest, take action, rather than having to download all the data and have it processed somewhere else and take hours or days to have this done real time. So very exciting.
I'm taking down notes as you're speaking, talking about Blackjack and Pit Boss. I think I know what their hobbies are with these folks, huh? Okay, let's lighten up the conversation a little bit, go from poker to Colorado University. I think your company is participating with them on a part of a competition sponsored by NASA called NASA CubeQuest Deep Space Derby. It sounds like a lot of fun, doesn't it? And so, from the way I understand it, you folks are putting together a small CubeSat that is going to go beyond Earth orbit. Talk about precision with communication. This is where it's seated. So, do you think we'll be able to communicate with Earth at that kind of distance, or maybe with your technology it can, huh? How far is it going to be away, by the way?
Well, it's the competition, as I understand, kicks off actually around 4 million miles away. But on that first launch, it's the Space Launch System, SLS, there's something like 13 CubeSats that are being deployed, and we have hardware on at least, I think, 10 or 11 of those. Yes, CubeSats. So for this particular one, we have a substantial part that we're playing. We have a great relationship with University of Colorado, a long history of collaboration. Worked closely with them in the beginning of the company, actually. We occupied some space on the university campus as part of the eSpace incubator at the time. And we've hired quite a few students from there. And shared resources and such, and work back and forth. But so they'll be using a C-band spacecraft, working with Atlas ground system, and I guess something like after 4 months, it will be about 4 million kilometers away from the Earth, where the competition begins, and they'll demonstrate communication with their system. And it's a matter of just how much data you get and the max data rate. So I have real confidence that they're going to do it. I mean, Scott Palo is running the group there. Excellent RF engineer and professor. He's done wonderful things with the program there, satellites and space classes.
NASA is encouraging this in order to proof of concept, or so why are they doing this, and what do you think they'll find? Well,
everybody loves a good competition. I mean, this type of competition goes back, back to Lindbergh, flying across the Atlantic. It's $25,000.
Yeah.
Nowadays it'd be like multiple millions potentially, but everyone loves a contest. Who's the first to do this, or who can be the best? The Olympics. Everyone loves to see a good race. So this inspires students and other companies to get out there, and even though they may not make a whole lot of money, it gives them a lot of notoriety, which on the back end they can certainly make money, get investments. So look what we did with this limited resource, so invest. And then it's a really safe bet for NASA because they don't have to pay anything out until awards are actually completed. And overall, the costs, what they're demonstrating to see that, can we get some new propulsion or some new communication demonstrated, far less than if they were to fund a program from start to finish with guaranteed results.
It's classic agile software development of iteration, testing, fail, testing. These are 10 tests going at the same time. Someone's going to win, and that technology will be improved upon. Well, Dan, unfortunately, we are running out of time here. I'd like to thank our guest, Dan Hegel, Director of Advanced Development, Blue Canyon Technologies.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.